Function f is x cubed for x less than -1, ax plus b when x is between -1 and 1, x squared plus 2 for x greater or equal to 1. We also know the function f is continuous. What are a and b? When I say a function, especially a complicated one, I would like to know the graph of the function. I would like to have a sense of what the function looks like. So I'll try to graph it myself. Well, this is the graph of x cubed without the restriction of domains. And the graph of ax plus b, even though we don't know the value of a and b, is a straight line. And the graph of x squared plus 2 is a parabola opening up with the lowest point at 0, 2. If we put the three functions together on their restricted domains, we got something that looks like this, where a circle point means that the point is actually not part of the graph, whereas a solid point emphasizes that point is actually part of the graph. For example, the point 1, 3 is part of x squared plus 2, whereas the point -1, -1 is not part of x cubed. As we can see, the function f would not be continuous unless the middle line segment ax plus b somehow connects the part of x cubed on the left and x squared plus 2 on the right. Well, the problem says the function f is continuous, so we know that the line y equals ax plus b passes 2 points, -1, -1, and 1, 3. Then it's not that hard to find the equation of the line. First, the slope should be 2, that is a is equal to 2. Now we plug in the point 1, 3 into the equation y equals 2x plus b and find out b is equal to 1. The problem is solved. I used the intuition that graph of a continuous function should not break up in the middle, but I didn't really use the definition of a continuous function, which is okay for a student to do. But the purpose of this video is not just showing you how to solve this problem, but teaching you the concept of a continuous function. A function being continuous has its rigorous definition, and I really want to demonstrate that. So I will do this problem again, but this time I will involve more of the formal definition of a continuous function. I'll still graph something to help me understand what is happening. So when x is less than -1, the function is given by the formula x cubed. When x is greater than 1, the function is given by x squared plus 2. Excuse me if I'm not drawing the precise graph because the precise shape doesn't matter that much right now. And then when x is greater or equal to -1 and less than 1, the function is a line segment. Again, a circle means that the point is not a part of the graph. A solid dot emphasizes that that point is part of the graph of function. By assumption, f is a continuous function, which means function f is continuous at any point that is defined. In particular, function is continuous at x equals to -1 and x equals 1. The definition of a function being continuous at -1 is limit of f of x as x approaches -1 is equal to f of -1. Now I will compute the limit of f of x as x goes to -1. This time I'll let x approach -1 from the left side. Then x will be less than -1 so that we know that when x is less than -1, f of x is equal to x cubed. Here the trick is, as long as the limit exists, it doesn't really matter how x goes to -1. And to compute the limit, we can simply plug in x equals to -1. On the other hand, f of -1 is defined, which is given by a times -1 plus b, which is minus a plus b. So we have -a plus b equals to -1. Function f is also continuous at 1. By definition, it means the limit of f of x as x goes to 1 is equal to f of 1. This time we'll evaluate f of 1 first. We simply plug in 1 into x squared plus 2 and we get 3. Next, I will compute the limit of f of x as x goes to 1. This time I will also let x approaches 1 from the left side, so x is always less than 1. When x is less than 1, f of x is given by ax plus b. To take the limit, we simply plug in x equals to 1. And we get a plus b. For the function f to be continuous, a plus b should be equal to 3. Now we have two equations of a and b. Solving them, we get a is 2, b is 1.